Hi everyone, welcome back to my channel, to our comprehensive course on machine learning with numerical examples and also Python. So, in today's video, it will be a little bit, let's see, theory, and up the next lesson, it will, of course, it will be more practical. And just because to give an introduction to machine learning, we have to go through some steps. Okay, and imagine, indeed, we need to know what is the machine learning, right? So imagine teaching a child to recognize, let's see, animals like cats. So instead of giving them strict rules like the cat has four legs and also it has a pointy ears and maybe it has a tail. So you show them, instead of that, you just show them some many pictures of cats, and over time they learn how to recognize cats in any position and also in any colors. That's exactly how machine learning works. So as you can see here, this is the machine learning, the traditional programming and also machine learning. So sorry, I have yeah, sorry for that, I have post. Okay, we in the traditional programming. Yeah. So unlike traditional programming where you have to write explicit rules, so machine learning allows computer to learn from the examples and improve with experience. It's like training a system rather than program it. So you can see here in the traditional programming we have a program with data and we have an output. Let's just consider it as a role-based system. For instance, if else, just keep it as simple as you can. And in machine learning, you have a data and you have outputs. For instance, if it's in case of classification, and this will give you a model. It's like a program. It's like if we consider a decision tree, it's like if else, for instance. And for the testing, you have data and using this program or the trained model to give you the output. So this is the difference between traditional programming and also machine learning. So as you can see here, the machine learning is a subset of the artificial intelligence. So hopefully you can see this image. Oops. Okay. So you can see this is the artificial intelligence. This is the outer circle, and this is the machine learning. So it's a subset of the artificial intelligence, and it's also you can see the deep learning. It's part of the neural network and also part of the machine learning. It's a subset of machine learning and also all of these subset of the artificial intelligence. So as you can see here, the main key, let's say, of the machine learning is that you have a data, it's learning data, it's learning from data, and the idea is to find some patterns, and that makes, let's see, some decision. It's if we again if we consider as a decision tree, it's like taking a decision. If the value is greater than specific value, specific threshold, just keep, for example, go to this direction or go to left or right. So you can see here, this is the data and this is the machine learning, training the machine learning. And why we see this is, just let me just go back. What is the, we see the difference between traditional program and machine learning. And as you can see, machine learning, to generate this model or program, it's go through several iterations. It's not only one iteration, for instance. So to make this model, it's try to learn from data and extract the insights from data to build this model. And you can see here, for instance, training, and this is the model build model, and this build model will be used for the tradition for the prediction. And don't worry, because this is somehow more theoretical part. But from the next letter, I'm promising we will go through several examples, and also with mathematical, with numerical examples. Okay, and if you see here the machine learning, it has different types. The different types, the first one is we have supervised learning. Think of it as learning with a teacher. So the algorithm learns from labeled examples like a student learning from the solved problem. Or let me give you another. So I have, oh, how to move this. Yeah, right. So the supervised learning, it's like it's working only if you have a labeled data. So if you have for instance image classification, you have the input image for instance for cat, and you have also the class label. So this telling the model that try to learn this extract some features from this image, and try to memorize it or try to generalize it that these features of of the image, it's a cat. And it's try to, for instance, in the beginning it will be classified as a dog, and we have for instance a loss function, and it will try to calculate the loss function, and will say it will tell the model that no, this is not a dog, it's a cat. And it will try to update the algorithm, the weights, until getting the final, let's say, the most correct answers. So this is the supervised learning. It has labeled data, and and also the data itself. And in the, or for instance, another example is for spam email detection. The system learns, for instance, you have sometimes you face emails move to your spam folder. Why it's moving to the? So because the algorithm is learn that if the model, for instance, contains some specific information or attach image, I don't know what kind of images, or let's say someone asking for money, this will be classified as a spam, and it will be moved directly to your spam folder. And for the supervised learning, we have two categories: classification. Classification, and also regression. What is the difference between this and this? The classification, the class label is a specific category. Let's see, categorical. So you have it's countable. For instance, I have cat, dog, and maybe some animals. So as you can see, the animals, it will be countable. But for the regression, the class label or the prediction, the predictor or the target is a continuous value, continuous. For instance, house price prediction. As you can see, you give the information of the, for instance, the area, the number of rooms, the number of where's the location of this house, and the prediction will be a price. So the price is not category; it's a continuous value. And let's move to the unsupervised learning. Unsupervised learning, you see, we don't have any class label. So the idea here is to find a hidden patterns from this data and try to categorize or group all similar stuff in the same group. For instance, let's assume that you have a set of fruits. Let's say apple, orange, carrot, and I don't know some others. So, but here, let's say you don't have any label for this specific fruit. So the unsupervised learning, it will try to group all of these similar, let's say in a sheep, similar stuff in one group. For instance, it will assign apple and orange in one group, and also let's say the carrot and banana in one group because they have different sheep. And this is the unsupervised learning. And in supervised learning, the algorithm try to find the patterns from data without any label. So you don't have any label. Imagine, let's see, sorting a basket, as I said, of this fruit, and you didn't need, you have no label. I mean, or let's say it's not needed. Let me give you a real example. So sometimes you need to detect the defects in images in the product line, let's say. But unfortunately, sometimes the class label, it's not, let's say, the defect samples are not easy to get. Assume that you are in a computer, let's say, computer chip uh, manufacturing or product line. So to get this defect examples, you have to make a defect manually, which is maybe it's more expensive for the customer. So the solution here is to use unsupervised learning. Try to learn the model with okay images that that's set manually by the customer, by the customer, let's say, and the system will try to learn, or let's say generalized information or extracting hidden pattern from these images, okay images, and compare it. For instance, in the inference time is compared with the other images, and compare the features if there any difference between the defect and non-defect. And the final one is we have the reinforcement learning. Let's say think of it as learning through trial and error. It's like teaching a dog a new trick through, for instance, through treat. Reinforcement learning algorithm learn optimal actions through reward and potential. Or for instance, uh, regarding the gaming, sometimes you just try this. For instance, open this door and or go to this direction. You have the result, and you will learn from this result. No, this, for instance, if I go to this direction, it will be, for instance, a big mistake. And this is only a reinforcement, let's see, example of reinforcement learning. So what are the application of machine learning? I mean, of course, no one, so as you can see, machine learning is now used in I will say in all applications. For instance, in business, it's used for fraud detection and customer behavior prediction, and also market analysis. And for instance, your smartphone uses, for instance, face recognition and also voice assistance. So it's try to so in a let's say in generally machine learning is used on all of the in our life, in any application. As you can see here is automatic language translation, of course, with this revolution with the chat GPTs and the DeepSeek and everything. It's it's using heavily machine learning. Also in medical diagnosis, if you have some images, for instance, you would like to classify or detect the tumor or any disease in images, it's also used in a stock market, and many applications. And also self-driving cars, which is you can see one example is as a Tesla or Chinese cars. And yeah, okay. And let me just close this session. It's of course theoretical, but I am promising you from next lesson I will try to start from scratch. Let's see, begin with installing the Visual Studio Code. Maybe it's maybe not. Maybe just preparing the environment, Python environment, so we can start directly to program. So I will start from this basic. Maybe it's not relevant for someone of you, but I will just try to keep it one complete course. Okay, so thanks for watching. If you like this video or and looking for any for other tutorials, please subscribe and hit like button. And if you have any question, of course, just drop it down in the below comments, so I will answer it when I have time. Thanks for watching and see you next time.